Hey guys, this is the notes for 4.5, solving rational equations. So let's go through the steps on how to solve them. So the first step is factor the numerator and denominator completely. Okay, so sort of like we did in the last section, we had a factor, right, when we could. Then again, we find our LCD. Okay, so just like in adding, subtracting, we also have to find the LCD. And then we need to multiply the numerators of each term by the LCD. So essentially what we're doing is the same thing as last time, except we're adding an equal sign. And then also one thing we can do is cancel out any factors, meaning our denominators will go away. So essentially, once we get all the denominators the same, they're going to go away. Right? And we're just going to simplify and solve for the variable. Okay, so we're just going to use the numerators. So our objective is to get all the denominators the same and then just get rid of them and solve the solution with just the numerators. Okay. So one key thing it says is make sure you check to see if your answers make an original denominator 0. So check for extraneous solutions. All right. Now, let's get into example 1. Okay, so what is our LCD? Right, so what we need to do is look at the three denominators. These have x's, right, and this has 5x. So our LCD is just 5x. Right, so that means this one is all set. This one is missing a 5, so we need to multiply the numerator and denominator by the 5. And same with this fraction right here. Okay. Now, once we do this, we'll get common denominators, meaning we can start solving. So we get 10 over 5x equals x minus 1 over 5x minus 5 over 5x. Okay. Now, all of these denominators are the same. So what we're going to do now is we're going to make them go away. Right? We're only going to solve for what's the numerator is saying. So we get 10x equals x minus 1 minus 5. Okay, so only the numerators. Now we're just going to solve for x. Right, so 10 equals x minus 6. Therefore, x equals 16. Right, and then now we need to take that LCD, right, and set it equal to 0 to find our extraneous solutions. Right, so x equals 0 is our extraneous solutions. Or in this case, extraneous solution, because there's only one. Right, so make sure after solving for x, you also solve for the extraneous solution, meaning you set that LCD equal to 0 and give me all of the solutions for x. All right, let's look at example 2. Right, let's find the LCD. So a lowest common denominator. This has a 3, a 2, and a 6. So we're going to have a 6 in our lowest common denominator, and then the lowest x term would be x squared. Right? So we need to get every denominator equal to 6x squared. So the first fraction, we need to multiply this by 2 to get 6x squared. So because 2 times 3x squared gives us 6x squared. The next one, we need to multiply numerator and denominator by 3, because 3 times 2x squared gives us 6x squared. And then the last one, we need to multiply the denominator and numerator by x, because 6x times x gives us this 6x squared. All right, now, what we noticed was once we did that in the last problem, our denominators went away. So essentially, because we found the LCD, we're only going to have to write the numerators now. So we need to distribute this 2 to both terms here. So we get 2 times 3x gives us 6x. 2 times 4 gives us 8. I'm not going to write the denominator. Then we get 3 times 5 is 15. And 1 times x is just plus x. Now we just solve for x. Right? So what I do is subtract 8. Right? So 6x equals 7 plus x. Right, and then subtracting x, we get 5x equals 7, and then divide by 5. You can just leave this as 7/5. You could put it in as a decimal if you really wanted to, but 7/5 is fine. Last step, check for extraneous solution. So we set our LCD, which is 6x squared equal to 0. Right, so x squared equals 0. Right, and the only x that's going to give us 0 would be 0, right? I'm just going to write E dot S for extraneous solution. All right. All right, so let's look at example 3. Now, the first thing, right, we want to do is we want to factor everything, right? So we can kind of see right here that this can be factored. So what we'll do is factor that out first. So 1 equals 1 over. They both have 3 in common. So I'm going to take out a 3. So we get 2x plus 1 left over when I factor out a 3. And then I have my original equation stays the same everywhere else. Okay. So now what we'll notice is, right, this is going to be our LCD, right? This 2x plus 1 is also featured in this, right? So this piece right here is only missing that 3 on the outside, right? So that's why we're going to multiply that by 3, right? So my LCD is going to be 3 times 2x plus 1. Right? If you really wanted to write it as 6x plus 2, you could as well. Oh, sorry, 6x plus 3. All right, it's up to you, okay? But I just wanted to show you what they were missing. That's why I wrote it like this and factored out. Then this 1 is missing everything. So 3 times 2x plus 1 and 3 times 2x plus 1. Okay, now, because we're multiplying out, our denominators are going to be the same. They're all the LCD, so let's write this. Oh. Let's rewrite this, okay? And then let's actually make this 6x plus 3 over here. So, right, we get 6x plus 3 instead of 1 there, and then equals. We did not touch this second one right here at all. So that numerator stays just 1. And then we have plus, right, 3 times 5. 3 times x and 3 times negative 5. So plus 3x minus 15. Now we solve for x, right? So I'm going to move the x over to the other side. Right, so we get 3x plus 3 equals, I'm going to combine my 1 and negative 15 as negative 14. Subtract the 3 over, we get 3x equals negative 17. All right, and then divide by 3. X equals negative 17 thirds. Last step, check for extraneous solutions. So if this is our LCD, set it equal to 0. we get 6x equals negative 3. X equals negative 1/2, right? It's just negative 3 over 6, which I reduce as negative 1/2, is our extraneous solution. All right, number 4. Again, we got to factor out. So let's factor. We can factor out this to p. Take out a p, we get p plus 3. Then this denominator here is the same thing, so p times p plus 3. All right, so our LCD is going to be p times p plus 3. Okay, so that means this fraction right here and this one are not going to be changed because they have the LCD. We just need to multiply this first fraction by this outside p. All right, so p over p. All right, so 1 times p is just p is equal to p minus 6. Then we have subtraction, so it's minus this whole piece. So minus 5p, and then minus negative 15 becomes plus 15. Okay, so then combine our p's, combine our constants, we get p equals negative 4p, and then plus 9. So we get 5p equals 9. Therefore, p equals 9/5. Again, just leave it as a fraction. It's easier. Then, right, we got to set our LCD, right, equal to 0. So p times p plus 3 equals 0. So we have two equations, p equals 0 from this p, and then we have p plus 3 equals 0. Right, we'll notice we'll have two solutions. Right, we can't do anything with that, so p equals 0. And if we subtract 3 to the other side, we get p equals negative 3. So these two are our extraneous solutions. All right, so the next one is a real world example of solving. Okay, so let's look at the information given. So it says one hose can fill a goldfish pond in 25 minutes. Okay, and then two hoses can fill the same pond for 20 minutes. Okay, find out how long it takes the second hose alone to fill the pond. So let's set these up as proportions. So let's look at hose 1. Right. So hose 1. Right. Let's put in the proportions per minute. So it takes 45 minutes. Right. That means 1/45 per minute. Right, because then 2 minutes would be 2/45 of it is filled, 3 minutes, so on and so forth. For hose 2, we don't know, right, how long. So let's set up the proportion 1 over x minutes, right, per minute. And then we said if they're both together, it says it takes 20 minutes, so 1/20 per minute. Okay, so, right, if we put hose 1 and hose 2 together, it's saying that it will equal them put together, right, the both hoses per minute. So let's add the proportions for hose 1 and hose 2 together and set them equal to what they get for both of them put together. Okay, so 1 over 45 plus 1 over x equals 1 over 20. Right, and you'll notice we're setting up sort of an equation for solving rational expressions. Right, we got to first find our LCD. Right, we have a 45, we have a 1 and a 20 for the coefficients. right? So our LCD for that, right, would be, right, it'd actually be 180, right, because 45 goes in 180 and 20 goes in 180, right? That's like the smallest number that both 45 and 20 will go into. And then the first fraction and the third fraction are both missing an x, right? That is right here. Okay, so the LCD is 180x. So now we just need to solve like we did before, multiply the fractions by what they're missing. So, right, 45 times what gives us 180x? Well, that'd be 45 times 4x. So multiply the numerator and denominator by 4x. What times x gives us 180x? 180. And then what times 20 gives us 180x? Well, that should be 9x. Okay, now we're going to get the LCD in our denominators, so we just need to solve with our numerators. So 4x times 1 is 4x. 180 times 1 is 180. And then that's equal to 9 times 1, which is 9x. We get 180 equals 5x. And x equals 36. So, right, how long does it take the second hose alone to fill the pond? Well, that would be 36 minutes. All right. So number 2 is pretty similar. I'm going to help you set it up, but at this point, I want you to try this on your own. So this says it took Paul 4 hours to paint a room. So, right, Paul equals 1/4 of the room per hour, right? Because the whole room takes 4 hours, so that means in 1 hour he does 1/4. Mike says 5 hours, so 1/5 of the room per hour. And then it says how much time would it take them to paint the room together, right? So that means both together would just be 1/x of the room per hour. Okay, so, right, what we need to do is add Paul and Mike together and set it equal to their rate for both, right? So 1/4 plus 1/5 is equal to that 1/x. Okay, so what I want you to do now is solve this problem on your own. You should get x equals 20/9 or 2.2 hours. Okay, so this is a solution. So I want you to try and figure out how you get to that solution. If you have questions, ask me on Remind or Google Classroom, and I can send you some directions with some voice memo with it. So for these next two problems, I want you to try them on your own. So I would like you to pause it now because I'm going to actually show the solutions. So please pause it now. Try these two on your own. And then I'm going to show you the solutions to 1 and 2 with the steps. Okay. So hopefully you tried these two on your own. I wrote out the steps on how to solve these. If you kind of see, I skipped a couple steps to show the extraneous solutions. Remember, just set this equal to 0 and this equal to 0. Same thing with this. That's how I get my extraneous solutions. The rest should be similar to how we solved the examples earlier in the lesson.